In this new unit, we will be studying trigonometry, which is the study of triangles and their sides and angle measurements. Our first lesson is called the Pythagorean theorem. This is one of the fundamental theorems of trigonometry. It deals with all right triangles. A right triangle is simply a triangle that has a 90-degree angle. This will be noted on the triangle by a little box in one of the corners. So this is a right triangle. The sides of the 90-degree angle are called the legs. The longest side, which is directly across from the 90-degree angle, is called the hypotenuse. The Pythagorean theorem is simply a formula relating the legs to the hypotenuse. This theorem works in all right triangles. So any triangle that has a 90-degree angle in the corner, the Pythagorean theorem will work. And the Pythagorean theorem simply states that if I square the lengths of both legs and add them together, that will equal the square of the hypotenuse. So a squared plus b squared equals c squared. A and b will always be smaller than c. So if you're ever unsure of which angle is the 90-degree angle, it is always going to be across from the longest side of the triangle. In our first example, the question is this triangle a right triangle? Well, notice the sides are 3, 4, and 5. Since 5 is the longest side, that means this would have to be the 90-degree angle directly across from it. So that makes 3 and 4 the legs, or the A and the B, and that makes 5 the hypotenuse, or the C. Now it doesn't matter which one of these is A and which one is B, the legs are interchangeable. So to see if this is a right triangle, I'm simply going to follow the formula. 3 is my A, so I would take 3 squared. 4 is my b, so I'll take 4 squared, and that should equal the hypotenuse, 5 squared. So now as I multiply these out, 3 to the second is 3 times 3, which is 9. 4 squared is 4 times 4, 16. And 5 squared is 5 times 5, or 25. Now if I add 9 plus 16 together, I get 25. Since 25 equals 25, this is a right triangle. So I would say yes. For our second example, the sides are 5, 7, and 9. Since 9 is the longest side, that means this must be the 90-degree angle. Now we are trying to determine if this is a 90-degree angle, so it's kind of a question. So I simply fill in the values. 5 and 7 are the legs, so I could make 5 be my A and 7 be the B. And again, it doesn't matter what order I do this in. This could have been A and this could have been B. It'll still work the same. But I do need to be sure that the longest side, 9, is my C. So filling in the Pythagorean theorem, I have A is 5, so 5 squared. B is 7, so 7 squared. And that should equal C squared, or 9 squared. If this is true, then I have a right triangle. 5 squared is 25. 7 squared is 7 times 7, 49. And 9 squared is 9 times 9, or 81. Now, 25 plus 49 is 74. You'll notice that 74 does not equal 81, so this is not a right triangle. So my answer would be no. One of the things we can do using the Pythagorean theorem is find a missing side of a right triangle. So in this situation, I know this triangle is right. Okay, I know this is a 90-degree angle. I simply want to find the missing side. You'll notice the missing side is across from the 90-degree angle, so the side I'm missing is C. Now I can fill in my equation with this information, and I will solve for the missing side. So a squared plus b squared should equal c squared. I'll call 12a and 16b. Again, it doesn't matter. I can switch those if I want. So 12 squared plus 16 squared should equal c squared. 12 squared is 144, and you may need a calculator for this. 16 squared is 256, and I'm looking for c. Now I simply add 144 and 256, giving me 400. And now I need to solve this for c. Well, the opposite of squaring something is to take the square root. So to solve this equation, I need to take the square root of both sides. So the square root of c squared just gives me c, and the square root of 400 gives me 20. So my answer is c equals 20. Usually the square root sign and the squared key are in a similar location on your calculator. Here's another example where I want to find the missing side. This is a right triangle for sure. Okay. You'll notice that this time though, I'm given the c, the value across from the 90-degree angle, and what I'm missing is either the a or the b. Again, it doesn't matter which one, so I'm going to call 24a, and I'll call my missing side b. So now I'm going to fill in the Pythagorean theorem. I said a was 24, so 24 squared. B is the one I don't know, so I'm going to leave that as b, but I have to square it. And c is 25. Now I simply square 24 and 25. 24 squared is 576. 25 squared is 625. And now I need to solve this for b. So my first move will be to subtract 576 from both sides. That cancels out, leaving me with b squared equals 49. And now to get rid of the squared, I simply take the square root of both sides. And the square root of 49 is 7. The square root, remember, is what two numbers multiplied together would give me 49. And since 7 times 7 is 49, the square root of 49 is 7. For this triangle, I am missing this side. You'll notice again, though, since I'm given the side across from the 90-degree angle, that's automatically the hypotenuse, or c. So these are a and b, in any order. So I'll call this one a and this one b. So I'm going to use the Pythagorean theorem. A is 40, so I take 40 squared plus b squared, which I don't know, equals 41 squared. Now 40 squared is 40 times 40, or 1600. And 41 squared is 1681. Again, probably use your calculator on that one. Now I simply subtract 1600 from both sides, solving for b. I have b squared is 81, so I have to think of what two numbers multiplied together would be 81, and they have to be the same number. If you can't think of it in your head, you could take the square root of both sides. The square root of 81 is 9, since 9 times 9 is 81. You may be given problems like this, where I simply ask, could these three sides make a right triangle? You have A, B, and C, so all I need to do is see if the Pythagorean theorem would work. Just filling in the values. So A is 12, B is 35, and C is 37. And I'm wondering if this is true. Well, 12 squared is 144. Again, maybe use your calculator. 35 squared is 1225. 37 squared is 1369. Add these two together. That's 1369. Since they are equal, yes, these three sides do make a right triangle. Same thing for this one. I'm going to fill in the Pythagorean theorem. A squared plus b squared, and see if it equals c squared. So 8 squared is 64, 9 squared is 81, 10 squared is 100. I think on this one it's pretty obvious. This is 145, and that does not equal 100, so the answer would be no. And I could also ask you to find a missing side. So this is doing it without the picture. But C is always the hypotenuse, and A and B are the legs. So to find the missing side, I would simply fill in the Pythagorean theorem. 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144. Add those two together. I get 169 is c squared. If I take the square root of 169, that will tell me what c is. And the square root of 169 is 13. For the last example, this time I give you the hypotenuse, but left out one of the legs. So I fill in my equation. So 24 is A, I don't know B, and 25 is C. 24 squared is 576. Again, use your calculator. 25 squared is 625. I would subtract 576 from both sides, giving me b squared is 49. Then I know that 7 times 7 is 49, so b is 7.